So this is the 2014 Leaving Cert Ordinary Level Paper 1 and we're looking at question 5. The function f is defined as f of x maps onto x cubed plus 3x squared minus 9x plus 5, where x is an element of the set of real numbers. Part A1 says find the coordinates of the point where the graph of f cuts the y-axis. Well, if you want to find the place where it cuts the y-axis, you let x equal to 0. That's how we find the y-intercept. So we change the x's in the function to 0. So this can be just written as f of x equals the function as well. This symbol here means the same thing. So f of x or f of 0 in our case, we're letting it be 0, is equal to 0 cubed plus 3 bracket 0 squared minus 9 bracket 0 plus 5. So when we put this into our calculator, you can see the first three terms just become 0, so you get 5. So that's the y-intercept. So the coordinates, if you want the coordinates would be 0, 5. That would be the coordinates of the intercept. Part 2 says verify that the graph of f cuts the x-axis at x equals to minus 5. So we have to verify it. That means we're going to substitute this into the equation here and see what we get. So this time we're going to sub minus 5 in for x, and we're hoping then if it satisfies it, if the graph cuts the x-axis at this point, well then we should get 0 when we substitute it in. So we get minus 5 cubed plus 3 on minus 5 squared. I'm replacing the x's here with minus 5. Minus 9 times minus 5 plus 5. So this gives us minus 5 cubed is minus 125. And 3 by minus 5 squared, this is 75. Plus 45 minus 9 by minus 5 plus 5. So that gives me minus 50, and then over here plus 50, which is 0. So there we verified that it cuts the x-axis at x equals minus 5 because f of minus 5 gives 0. Okay. Part B. Find the coordinates of the local maximum turning point and of the local minimum turning point of f. So the turning points, the max and min turning points, max turning point and min turning point. The way we find turning points is we find the derivative of the function and let that equal to 0. So remember, the function f of x is equal to x cubed plus 3x squared again, x cubed plus 3x squared minus 9x plus 5. So that's our function. So if we're going to differentiate this function or find the derivative, we're going to use this differentiation rule here from the tables book. So to use this rule, you should know this off by heart. To find the derivative f dash x of a polynomial, we differentiate each term individually. So the differential of x cubed, bring the power to the front and reduce the power by 1. So it's 3x squared. Plus, bring this power to the front, times it by the 3, 6, x to the power of 1 if you like. Again, minus 9x, x has a power of 1. When we bring that to the front, it becomes minus 9 by x to the power of 0, and x to the power of 0 is 1, so it's just minus 9. And the differential of a constant is 0. So that's our f dash x there. So you can ignore the 1 power there, so 6x to the power 1 is just 6x. Okay. Now we want to know, where is this equal to 0? This is the differential. So we let this be equal to 0. And that will give us the x coordinates of the turning points. So this gives us a quadratic equation that we can solve. We can use the quadratic formula, which I've also taken here from the tables book, or you can divide everything by 3 and factorize. So I'm just going to use the quadratic formula. So remembering, my a value will be the number in front of x squared. My b values will be the number in front of x, positive 6. And the c value will be the constant at the end, which is minus 9. So what I get then is x is equal to minus b, which is 6, plus or minus the square root of b squared minus 4ac. So I'm replacing the letters with brackets. B is 6, a is 3, c is minus 9. And that's all over 2a, which is 2 times 3. So we do this on our calculator, once with plus in this place and once with minus, to give us 2 separate answers. And the answers we get are minus 3 and 1. So they're my x values, minus 3 and 1. So we've got the x coordinates of the max and min turning points. So to find the y coordinates, we sub each of these individually back into the original function here. So we're going to do that now. I'm going to do this here. So f of minus 3 into the original function now will give me minus 3 cubed plus 3 by minus 3 squared minus 9 by minus 3 plus 5. I put all of this here into my calculator and I get 32. So that means one of the coordinates is minus 3, comma 32. Then I'm going to do the same thing with my other x value, 1. So the f of 1 is equal to 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So putting all of this here into my calculator gives me a value of 0. So that means that the other coordinate is 1, comma 0. And then I can see from looking at these points or imagining them that minus 32 is higher than 1, 0, higher up. So this would be the max. And this one here would be the min. So that's the end of part B. Part C then finally says, hence, which means using what we've just done, sketch the graph of the function f on the axes below. Okay, so sketching the graph means it doesn't have to be exact every single coordinate, but just roughly get the intercepts and the general shape. That's what the sketch is. So what do we know so far? We know, well, first of all, it's a cubic function. Now, the x cubed coefficient is in a 1x cubed. X cubed is 1x cubed. So because that's positive, we know that the cubic will have this general shape. That's positive. If it was negative, the number in front of x cubed, that is, you would have a cubic looking like this going the other way. So we know it's this general shape here. We know that the y-intercept is 5, and we have our max and our min points. So let's mark this. The y-intercept is 5. This is the y-axis, or the f of x axis, same thing. So this is going 15, so 5 would be here. That's the y-intercept. The max is minus 332, which is over to minus 3 and up to 32, which would be somewhere like there. The min is 1, 0. So we go over to 1 and 0, that's our min point. And we also know from this part 2 that the graph cuts the x-axis at minus 5. So the x-axis also gets cut at minus 5 here. So we can see the general shape has to go through all these points. So our curve then, which is cubic, as smoothly as you can, you draw a shape like so. So that's the general sketch of the function f with all the important intercepts and max and mins marked in. So that's the end of part C and the end of question 5.